Okay, so hi everyone. This is my first video. I'm doing this because I want to improve my English. I think it's not very good. I might be good reading, listening, but my speaking is just trash. At least that's what I think. So I thought about coding my journey through machine learning or deep learning research, and that would help me to improve that. And I wanted to get good at explaining things. So yeah, I guess this is a good combination of things to, and so I think this is a good way to achieve that. Okay, so some time ago I watched for first time to Alexa Gardic channel on YouTube explaining some projects that you can make in order to improve through machine learning implementation skills, or yeah, because I guess this is the best way you can get good at it, right? I mean, you grab a paper and then you implement it. I think that's how research should be done. uh, I mean, in whatever field, you grab a paper, reproduce results, and do the same. And so what I did is grab the first suggestion from Alexa, which is doing a neural style transfer algorithm, but I did a vanilla version, which means I did a simpler, simpler. I don't know if that's a word, simpler or more simple. I am okay. So I decided to do a simpler version, which means I did a more or less 100 lines of code implementation of it. Of course, it is less refined than the one did by Alexa, but it works. So I guess it might be easier to follow. Maybe it's not the best way to do code, but I mean, this is my first attempt. Okay, so the idea of the paper is you have a target image. It could be a photograph. I mean, in general, it's just a photograph, something very detailed. For example, here I have a bridge. I don't know where this is. And then we have a style image. I mean, we want to capture the textures, the style of this image, and somehow transfer it into the target image. So, for example, the combination of these two images gives this. And I also did experiments with the Starry Night artwork. I don't know. I guess I should open this style. And for example, if I use this bridge image and combine it with the style of Starry Night artwork, I get the following. All right. And so I think this is another example. Mosaic. If I combine this with a photograph of another bridge, I think it's called the Golden Bridge, I get a following. And now it's not a perfect transfer, but I think I know the reasons why it's not that perfect. Uh, but well, that's not the point. The point is that like it works. I can see the transfer in style. Um, so the reason it's not that perfect is because of the size of my images. That's at least why what I suspect. I had to resize my image to 256, and because if it's 512, it is just too much for my GPUs. So how I managed this project? So by reading the paper, I saw that this could be partitioned into two tiny projects. First, you can do a style reconstructions. You can do the style reconstructions, which means grabbing an artwork and then through gradient descent, through optimization, we can get from a white image, and we can get from this image a somehow capture the texture by using ground matrices. And then the other project would be a reconstruction of the content image, which means starting from a white image, we should reconstruct the original image. Now, we are using transfer learning. We're using a BGGNet 19. I guess you I guess you can use another ones like 16. But the thing is that if you use shallow layers, you get, for example, for constant content reconstruction, you get almost perfect reconstruction of the image. And the deeper you go, you get like you lose details in the pixels, which is kind of the idea, right? You don't want a perfect reconstruction of the image, but instead you want to lose a little bit of detail so that you can combine it or embed the style of the artwork. And so that's what I did. I first did this, and once I had them, I just had to combine it into a big loss function, which is not big. It's just the combination of the loss function of the two of them, but we have to put weights. For example, if we put a lot of weight into the loss function of the content, we will get a like perfect reconstruction. If we put a lot of weight into the style image, then we will get just something like this. But we want something in the middle. We want to preserve enough details of the content image, but we also want to lose a little bit of detail so that we can embed the style. The way the architecture, well, the proposed architecture is this one. Basically, you build, well, it's not precise what I would say, but I guess it would help in understanding what is happening. So imagine you have like three BGG nets. You use the first one to compute the style like representations. Uh, we choose 5 layers. We choose 5 layers. For each layer, we get we do this reconstruction for the style image. For the content image, we imagine we have another BGG net, but we do the reconstruction in the fourth convolutional layer. And for the style reconstruction and contour reconstruction, we calculate their corresponding loss functions, and then we combine it into the total loss function. And as I said, we have to put weights on them. And well, in the paper they present some examples. I also did mine here. I think it's very empirical in the sense of choosing these hyperparameters. For example, for them it worked ratios of 10 to the minus 3, or this a times 10 to the minus 4. But for me, the ratios that worked were 1 over 70 or 1 over 10 to the 2. So I guess it depends a lot on the layers that you choose. Uh, I think Alexa chose like the maximum feature number that he chose, I think it was like 27 or 30, while I choose something like, where is it? I can see it. While in my case, I choose like 40. So I think uh, that plays a big role. And well, that's it. And thanks for being here.